few weeks ago, my nephew, who is a fifth grader, 12-year-old, came to me. He's a lot into manufacturing and technology. So he came to me and asked me if I can help him design an aircraft, a kind of like sci-fi looking aircraft for his school. And like any other startup CEO these days, I delegated it to AI. So we opened up a chatbot and started with a few simple prompts first. Got a simple design initially. And it's magical. You change the prompt. It gives you something more cooler. We asked it for like a bigger wing. It made it bigger. Titanium skin, sleeker aircraft. Eventually, we asked it to give us a super fast, hypersonic aircraft. And this sci-fi looking SR-71-esque aircraft kind of jumped out of the screen. So he was pretty excited. He was pretty satisfied with the results. And I felt pretty accomplished, even though I didn't do anything. But then he asked me a question that kind of gave me a pause. He said, hey, can you actually make this in your factory? It gave me a pause because I used to be him 23-something years ago. I was in high school. I was super amazed by the fact that you can turn any idea that I had from ideation to reality on a computer screen with just a few lines of code. So that put me on the path toward engineering, software engineering, until 15 years ago. 15 years ago, I got the first time tour of SpaceX factory. And it was honestly a spiritual experience. I saw rockets being built. I was like a kid in a candy shop. I was like, this is the most ambitious projects I've ever seen. I really want to be part of it. This is what my life is about, right? So I joined SpaceX, but soon I realized that the speed of innovation, the speed of iteration, even at a company like SpaceX, is orders of magnitude slower than the software companies I was before that. Sorry. So I set my life mission at that point to work on making development of hardware as fast as software. I spent some time at SpaceX. After that, I joined part of the early founding team of a company called Relativity Space. Using 3D printing, I was in charge of a team that was developing a 3D printing method to kind of speed things up. And then 5-6 years ago, started Machina with a co-founder to really solve this problem at the root. Build a system that can turn any design, any idea, into a physical reality as fast as we can come up with them. And this is not something that I am only concerned about or my nephew is really excited about. I think this is something we should all be concerned about. Because with AI, all of our customers are now using it to come up with these amazing designs of the things they want to see. They're designing their own cars, their own planes, and they're putting it on social media. They're turning their imagination into actual visual designs, and then they're collaborating in the comments section. The next person comes up with a slight iteration and put it on, and they're tagging everybody in this room, and the companies in this room, and asking them to build it. Well, we all know that factories today are stuck. The reality is stuck. As fast as AI has turned imagination in terms of speed, the reality of physically building products is still stuck. Factories are temples of repetition, right? One die, one mold, millions of parts, millions of copies. The moment you want to change it, you have to spend significant amount of money in tooling and CapEx, refacilitization. That means month of lead time as well, right? And if the product doesn't work, you have basically a warehouse full of products that you cannot sell. So that's the problem we set out to solve at Machina Lab. We build a robotic system, we call it RoboCraftsman. It's to my left, to your right. It's a robotic system that operates like a craftsman. It can pick up different tools, intelligently apply it to different material, and do different types of manufacturing processes autonomously. We started from sheet forming. It forms sheet metal the same way a sheet shaper, hammers and deform a sheet into shape, into a complex shape. It then it doesn't stop there, right? That's sheet forming with no tooling, just from software, turning a design into actual final product. But it doesn't stop there. After it's done with forming, like a human, like a craftsman, can drop the tool, pick up the next tool, for example, a trimmer, trim the part. Figure out how to trim the part and then trim the part. And then drop the tool, pick up the next one, maybe a scanner, scan what it did, use the data to create quality reports, or even use the data to train models, artificial intelligence models, that enables it to figure out how to improve its process and do the next operation, right? So you're catching the drift. We're constantly teaching it new operations. We're teaching it heat treatment, trimming, forging, additive manufacturing, welding. So we're constantly giving it a new tool and showing how it can do a new operation. And we built this system, and the customers came. Metal structures today is $650 billion industry. It's expected to become $1.1 trillion industry in the next decade. And the need for agile, on-demand, fast sheet metal products, roughly for $150 to $200 billion today. And that's given that there is no real agile solution that can service this market. So given the limitations, that size of the market. We work with our aerospace customers, aerospace primes, to manufacture missile, UAV, airframes, and metal structures 4 or 5 times faster than traditionally was possible. We are working with our military today to increase their mission readiness. Military operates 50, current US military, operates more than 50 weapon systems. Some of these weapon systems are 50 years old. When a panel on one of these aircrafts gets damaged, that aircraft stays grounded until you have a replacement panel. That can be up to 4 years today. That means that 4 years, that aircraft cannot do missions. We're turning that into only a couple of days, few days. We're also working with the Air Force to restore historic aircrafts. We're working on a B-17 World War II bomber that we're restoring today, something that wasn't traditionally easily, practically doable. And we're also working with Navy on not only making boat hulls faster, but also making them near the point of need, right? Because our system is not a giant centralized factory. We can ship it anywhere. We can set up a facility real fast. This is what I call expressive manufacturing, where you can build mobility products. You can build cars, aircrafts, boats, submarines, as fast as we can design them. But if we're making mobility products faster, why not also making the factory itself faster, right? And the key to that is to make the factory itself mobile, right? So we can ship it anywhere, easily deploy it, and set it up real fast. That's what we wanted to show today here also at UP.Summit. So the RoboCraftsman system that you see today, it's actually 2 containers. It comes in 2 containers, 2 ISO standard containers. It can open up like a butterfly, like a transformer. In the same day, it can actually self-calibrate on any warehouse floor as long as there's power and start manufacturing components, right? We are nomad species, right? So we want to be able to have technologies that move with us. And as a matter of fact, the power that runs this system is from a generator that's designed by Toyota. It's a hydrogen generator that's designed by Toyota that fits on the back of a pickup truck. It's actually in that Toyota Tundra that you see next to the system. It can operate this cell for days. And the fun fact is that Toyota Tundra, the tailgate of it, has a custom manufactured tailgate that was done with the same RoboCraftsman. So this is pretty important, right? Because we are a nomad species. We want to go to space in the future, and we cannot take our manufacturing with us. Tomorrow, if you land on Mars, we cannot take a 4-story stamping press with us. But we can take RoboCraftsman in the fairing of Starship, open it up, and turn panels on the Starship into shelter roof tiles, into ramps, and reuse them. Speaking of Toyota, I would like to also announce the big news here on stage at UP.Summit. We want to announce a partnership with a visionary partner. Toyota is the biggest OEM in the automotive world, but they also have a vision where everybody can have a car that's uniquely expressing themselves. A serial number of one that everybody can drive, right? So I would like to introduce my friend and colleague, Zach from Toyota.
Man, I loved your story. It got me thinking about what are the common threads that we share. You see, I come from more of the hardware world. I grew up on a farm using my hands to fix tractors and build fences. So no wonder my engineering career landed me in a space like automotive tooling. But back to Ed's story, I do share a passion for innovation and pushing the limits. And my team gave me a suggestion that I need to go see what Machina Labs is doing. And I was immediately excited about what I saw as the potential of the RoboCraftsman and where it might possibly lead us together. So, at Toyota, we've spent countless decades trying to master one thing: high volume, low variation production at the very highest quality. Now that strength makes us Toyota. But there's always a catch. The same efficiency that makes us really great at mass production also makes it really difficult to deliver true customization and make a profit. And that's a bit of a problem. You see, in 2024, the US truck market for customization and accessories reached $2.4 billion. These customers, our customers, are asking for more personalized, more expressive vehicles. And we want to deliver that. So that's why, we are excited to explore these types of possibilities with a company like Machina. Their RoboCraftsman cell is the exact opposite of what we're good at. It thrives in low volume, high variation environments. So instead of us building and storing 20-ton dies, each variation can become digital and flexible and more virtual. And add a small impact to our regular production. And that keeps our mass production strengths intact as Toyota. All of this put together can get us closer to giving our customers the possibility and the uniqueness of that serial number one of one that Ed mentioned. Thank you for listening to me. I'm going to hand it back to Ed to take us home here.
Thanks, Zach. So, if you're making custom cars, expressive cars, what else? What else exists there, right? So, we asked the online community, what would you want to build if you could build anything? And thanks to AI, the variety of design is it's just astounding. It's Cambrian explosion of ideas and designs. And actually, honestly, it a lot matches what we're seeing here in UP.Summit, right? And this is the future I would love to be able to live in. I think it's the future we all, at least people in this room, would love to be able to live in, where, expression is not just about the words. It's not about computer screens. It can actually turn into physical 3D reality that exists in our physical world, right? So that's the future we're trying to build. We'd love to partner with all of you to build that. Before I wrap it up, remember that kind of aircraft that we designed with my nephew in the beginning of the slides? RoboCraftsman today is actually building the body of that aircraft, right? So make sure on your way out, check it out. It's a pretty cool plane, and thank you so much.
The future is gonna be awesome.